Hello guys. So this is gonna be our lab for acceptance sampling. Right. So in this lab, we'll be using this guide. Right. So I've uploaded it on Moodle. It's fairly detailed, so I advise you guys to go and look at it. Right. It will probably explain things better than I will write. So I've compiled this guide for you and I've uploaded it on Moodle. Right. Okay. So now these are just some lab rules, okay? So now we'll be doing acceptance sampling. Right? So acceptance sampling, we it's used by manufacturing firms, right? So let's say like a huge number of products are coming, let's say maybe like 12,000, right? And they want to make sure that those 12,000 products are defective free in a sense, right? Or they have the least amount of defectives, right? So acceptance sampling is conducted whereby from that entire lot, that 12,000 products, which we call a lot, right? A sample is a sample is taken from that lot, right? And then they inspect that lot, and then they have what you call an acceptance number, right? So an acceptance number, it sort of like defines the minimum amount of derivatives that they're supposed to take, right? So if they are C, let's say for example, if their C or acceptance number is equals to 2, right? It means that the maximum amount of derivatives that they are willing to take is 2, right? Which means the probability of acceptance for that as for those particular products is if they're accepted if they find 2 or less effective, right? So here right they're saying like the reason why we would use acceptance sampling includes when you're dealing with when you're dealing with unproven suppliers, right? During startups and when making new products, right? And then when the components can be damaged during shipping, and then when you're dealing with sensitive products that can be easily damaged, and then when the products can be spoiled during shipment, right? And then when the product has had quality problems in the past, right? So maybe like from these statements that I just said now, I think you get the point of why you have to use acceptance sampling, right? So, so like one other thing that like acceptance sampling in some instances it's not used, it can be used within a company, right? If maybe a company wants to ensure that they are not producing defective products, right? So let's say they want to like sort of like inspect their process or whatnot, they can also apply acceptance sampling to do that, right? So an acceptance sampling plan, right? It may differ from company to company. Some companies they have a single a single plan, right? And then there's a double plan, and then there's sequential, and then there's different sets of sampling plans that I won't cover in this lab, right? So in this lab, we'll be only focusing on single and double sampling, right? So when you do a sampling plan, right, what is known as an OC curve is created, which is used to assess the probability of acceptance for a shipment, providing the existing quality of the shipment, right? So in judging a sampling plan, it is desirable to know the probability that a lot is submitted with a certain non-conforming percentage, right, will be accepted, right? So that's why they have the C value, right? So obviously people know that like which called in companies you can it's almost impossible, right, for you to be able to produce like 100% defective free products, right? So as a company you'll be willing to acknowledge that, but you have a limit which is defined by your civil, right? So now here, one thing I also want you to notice, right? So I want you to notice as they vary the value of C here. So like if you look at when C is 0, right? They only accept when they find zero defective, which is exactly here, right? Which means like the entire sample has to be conforming, and then when C is 1, the area under the curve now increases, the accept when think the probability of acceptance goes down to 60%, right? And then when C is 2, the probability of acceptance, increases seemingly. And, oh wait, so yeah, my mistake. So when the C is 0, means they want the lot to be 100% conforming, right? And then when the C is 1%, the the probability of acceptance decreases from 100 to somewhere here. I think maybe let's say 90, right? And then when the C is 2, right, the probability of acceptance also decreases, right? Because like as the C goes up, they risk like accepting more defectives, right? So now, okay, so now we'll start with a single sampling plan, right? So a single sampling plan, it's involved when they're taking only one sample from the lot and then using the number of defectives to decide whether to accept or reject the entire lot, right? So sampling plan consists of a lot size, a sample size, and an acceptance number, right? So let's say, for example, like they're saying a fresh produce store evaluates fresh lettuce using a single sampling plan with a lot size of 3,000, and then from that plan they take a sample size of 89, right? And then an acceptance number of 3, right? Which means they accept only 3 or less defectives, right? So now we're gonna open our Excel, right? So in our Excel, right, so we're gonna have what we call an assumed process quality, right? So first I wanted to merge and set up this, right? So here, just open this up and then onto rep this test, right? So I don't get the step when I'm typing. So we have what we call an assumed process quality, right? So an assumed process quality, like it's the number of defectives, right, that they expect to find, right? So like this, it's pretty much an assumption, right? Like they may say, like you may find 1% defectives in the sample, 2%, 3%, whatever the assumption is, right? So we start from 0 because they might find 0, and then 0 0.01, 0 0.02, right? And then 0.03, let's say up until 10%, right? So we select this, and after we type, and then we drag it to maybe 0.10, right? Or 0.1, right? And then, so yeah. And then now, can you just, let's say I'm trying to move this down so I can type here, right? So this is gonna be your assumption, right? Your assumption of like the probable like defective or non-conforming product you might find in the lot, right? So you call this PO, right? Probability of non-conforming, right? And then what you're gonna do is that you're gonna multiply this by 100, right, to get the percentage of expected percentage of non-conforming, right? So you say, now you just say this multiplied by 100, right? And then you drag your formula up to here, right? So now after you are done, right, in a separate column, right, I want you to write the lot size, which is n, right, capital letter N, right, and then sample size, and then your C value, right, which is, let's say, acceptance number, which is C, right? So let me just open this up so it can be clear for you. Just see, and then this is gonna be small letter n, right? So our lot size, as was given here, our lot size is 3000, right? And then our sample size is 89, right? And then our C value is 3, right? So now after we're done with the I'm putting this value, we're gonna come back to our table, right? So here we're gonna input our sample size, right? Our which is our n, right? So our n, we are just gonna say equals to, and then this is our sample size, right? So we're gonna get this formula, right? And then we're gonna freeze this cell, right? Because our sample size remains consistent like throughout the different number of defects that we expect to find. So now since we've frozen this cell, we just drag, right? And then from after we drag, right, we calculate what we call the NPO value. Right? So before I calculate the NPO value, let me just explain what it means, right? So now if we go down to here, right? So with the acceptance sampling, right, the probability distributions like such as the binomial distribution, right, it can be used to determine the probability of acceptance slot, but the Poisson distribution, it gives a more accurate approximation, right, when you determine the probability of acceptance. So that's why it is the most commonly used when it comes to acceptance sampling, right? So this is a formula for the Poisson distribution, right? So now you can see, like, for the formula to work, right, there's this value, right, NPO, right, which is here, it's the average number of events for a given classification in a sample, right? So now we sort of like, let's say it's the, like, let's say since we have a sample of 89, right, it's the proportion of non-conforming that we're expected to find. If we, like, let's say from 89, right, let's say, so that since now your NPO, right, the expected number of this PO is the expected number of defectives. So now the proportion of the defectives, it's gonna be this, like from this 89, you might find 0.0, let's say this is this one. So from that 89, you might find 0.01% of non-defect of the product, right? So it's a proportion, it's the proportion of the sample, like given that we find 1% defective, and then proportion of the sample if we find 2% defective, right? So now here, like, for us to calculate, to do a Poisson distribution, right, you have to calculate the NPO value, right, and then you'll see where it adds up, right? So now calculate our NPO value is simply multiply this PO, or proportion defective, by n, right? And then we press equals to, and then we drag our formula, right? So now since you are done with the NPO value, right, so now we calculate our probability of acceptance. So our probability of acceptance, I'll name it PA, right, which is probability of acceptance, right? So okay, let me just make this big, which is gonna be probability of acceptance, right, which is PA, right? So as I was saying, right, your Poisson distribution is the most accurate, like, this probability distribution to forecast for, or to determine the probability of acceptance in acceptance sampling, right? So our Poisson distribution in Excel, it's given by, so when I say equals to Poisson, and then as you can see, there's this Poisson distribution, right? And then this one, it's threatened Poisson test, right? So now you can see it has three matrix, right? It has X, it has the mean, and then it has cumulative, right? So if you go back to my slide here, which is more clear, right? So it has three functions, right? Which is our X, right? Which is the number of events, right? And then our mean, right? Which is the required number of events or required, right? And then we have our cumulative, right? So how our cumulative works, right, is that our Poisson distribution, right, it calculates the probability, right, in a cumulative sense, right? So if you say like if like so now if you say if the cumulative is true, right? If say cumulative, if you okay, so let me start here. So cumulative, it can either be one of two things, right? It can be true or false, right? So now if you put cumulative as true, right, you're gonna get a cumulative probability of acceptance, right? Which you're gonna get something like probability of like two or less or whatever that value is or less, right? But if you put it as false, right, you're gonna get a probability of acceptance at exactly that point. So if you're looking at probability of acceptance at 2, you're gonna get a probability of acceptance exactly 2. But if you put it as true, you're gonna get a probability of acceptance at 2 or less, right? So that's very important. You're gonna see how important it is when we're doing our double sampling plan, right? So coming back here, right? So our x, right? So our x is given by our acceptance number, which is 3, right? So when I select this 3, right, and then since our acceptance number is 3, right, it's gonna be consistent throughout like these different defective, like expected defectives of products, right? So now I have to freeze this, right, and then from then on I have to put in my mean, right? So my mean is my NPO value here, right? And then now, since we are looking for a probability of acceptance at 2 or less, right? We're gonna have to put it as true, right? As true, right? And then we close, right? So let's say let's run an experiment now, right? So let's say I were to put this as false, right? As false, right? So this is just I just want to demonstrate something, right? So and then I drag this throughout, right? So now my probability of acceptance, since my acceptance number is 3, my probability of acceptance is going to be P of 3 or less, right? So since I put this as like false, right, which means not cumulative, for me to get like this 3 or less, right, I'll have to, so 3 or less, like you can determine it by adding when the probability is 0, right, plus when the probability is 1 here, right, and then plus when the probability is 2, plus when the probability is 3, right? So now this is 3 or less, right? It's probability of 0, probability of 1, probability of 2, and probability of 3 as a sum, right? So now this is probability of 3 or less, right? Which is 0.42, which is 0.42. Wait, so 0. Okay, so now if I put this as true, right, and then I drag, right, so now my probability of acceptance is 72%, right? But now, like if I was to put it as 3 or less, right, it's gonna give me, so now I get, like if I put it as true, right, if I put my thing as true, I get a cumulative probability, right? Which means like now, as you can see, like the higher the acceptance number, the lower the probability of acceptance, right? So here now, like now I can, to get my percentage of acceptance, right, 100 PA, right? So let me just clear this, clear my content. So now to get my percentage of acceptance, I'm just going to type percentage of acceptance, right? So I get my percentage of acceptance by multiplying this by 100, right? So now after I multiply this by 100, I can now drag my formula like this, right? and then I can ensure that I reduce these numbers to make it more clean, right? So now, since my probability of, so before I get my probability of acceptance, right? So I can sketch my OC curve, right? So the OC curve, your X is going to be given by the probability, the percentage of non-conforming, right? Against the probability of acceptance, right? So now after you've selected these points, right, you're gonna, sorry, you have to select this and this, right? After you've selected them, you go to insert, right? And then you go to recommended charts, right? And then you go to all charts, right? And then you go to scatter, right? After scatter, you're gonna select scatter with smooth lines and markers, right? And then when I select this graph here, right? So now this is your OC curves for a single sampling plan, right? So one thing I want us to do, I want us to fix our exits, right? To justify them, right? So since your highest point is 100, right? I want you to justify this here, right? So you double click on your axis points, right? And then you put this at 100, right? So now you can see your your y-axis adjust, right? And then you double click on this on the x-axis, right? And then after you double click on it, you're gonna get minimum and maximum, right? And then you're gonna reduce your maximum to 10, right? So now you can see your OC curves starting to take proper shape, right? And then now I want you to insert your labeling, right? You want you to label your x-axis, y-axis, right? And then your, okay, so title is already there, right? Yes, I think this is pro. So now your x-axis, right? It's gonna be, let's start with the title electron. So your title is gonna be OC curve for a single sampling plan, right? And then your x-axis is gonna be, so now since this is the expected proportion non-conforming, right? So this, you're gonna label it as, you can say proportion non-conforming or percentage non-conforming, right? So you can say, let's say percentage non-conforming, and say your percentage non-conforming, right? Which is your 100 PO, right? And then your x-axis, it's gonna be your percentage of acceptance, right? Which is gonna be your percentage of acceptance. It's gonna be your 100 PA. 100 PA, right? And then now you have properly done your OC curve, right? So now after you are done with your OC curve, right? So now you can determine your probability of acceptance, right? So you can determine it from, so you can determine it from the graph, or you can determine it from your data, right? So from your data, right, since your probability acceptance number is 3, right, it's gonna correspond to this, which is the expected defective, right? So as I said, since this is cumulative, right, so like your probability of acceptance for this lot, right, it's gonna be given by 72%, right, which is sort of like, if you extrapolate from here, it sort of corresponds with this point, which you can get from your graph, right? You can just get it by clicking on your graph, right? And then under chart elements, right, you look for labels, right? So So you can look for data labels, right? So let's say you say on top, right, which is here, right? And so now you can see that this line, when it's three or less, right? So three or less defective, the chance of acceptance is 72.07%, right? So that's your probability of acceptance, right? So now that's how you do a single sampling plan, right? So in the next video, I'll be going over a double sampling plan. But before I conclude, let me check if there's anything that I'm missing that I didn't cover. Okay. Okay, yeah. So there's the matter of the producers and mm, the that's an older guide. So let me see. Yes. So this is what I wanted to cover, right? So there's what is called the producer's risk, right? So the producer's risk is defined as the probability of non-acceptance of a conforming lot, right? So now the producer's risk, right? This usually happens, let's say when, let's say like companies, like they usually have like an acceptance number, right, and a rejection number, right? So let's say they have an acceptance number of three, but their rejection number, let's say it's six, right? They reject, they completely reject the lot if they find six, right? So let's say they find four for argument's sake, right? So now it's a bit inconclusive on what they should do, right? So now that's where factors like that come into place, right? So the producer's risk, right, it's a proportion of non-acceptance, right? So it can be extracted straight from the OC curve, right? It's given by alpha, right? So since the probability of non-acceptance of a non-conforming lot, right? So this here, it gives you the percentage of acceptance of a conforming lot. So to get the probability of acceptance of a non-conforming lot, you have to say this minus this, right? Or it's probability of non-acceptance, basically. Like it's probability of to get the probability of non-acceptance, you just say since probabilities are of one, right? The probability of acceptance and the probability of non-acceptance, they add up to one, right? For you to get the probability of non-acceptance, you just say use that method. So which means if you transpose this to the other side or this to the other side, you'll get probability of acceptance equals to one minus probability of non-acceptance, right? So the precise risk is associated with the what we call an AQL, right, which is the lowest tolerable processed average for a continuing series, or the lowest quality that you can accept, right? So now, if like let's say now you get your AQL as, so now if you say a probability of acceptance, right? If it's when a probability of acceptance, and then you maybe let's say it's gonna be, let's say let's use this graph. So probability of acceptance, it's gonna be, if you are using this graph, right, the probability of acceptance, it becomes 95%, right? So your LQL, you determine it by extrapolating from here and then down here, right? And then you can determine your AQL, right? So your AQL indicates lowest the lowest quality level that the company might be willing to accept, right? So now the consumer's risk, right, is the probability of acceptance for a non-conforming lot, right? So the producer's risk, like it's basically associated with the consumer, right? So the producer's risk, right, it's associated with the supplier, right? So the supplier, like they might be producing a good lot, right? But the consumers, right, that are receiving the sample, right, they might be they might like find more defective while the entire lot is good, right? So it's a risk associated with the producer, right? But the consumer's risk is the risk associated with the consumer. So the consumer may risk affecting, like selecting a non-conforming lot, right? And then a non-conforming lot So now this risk, yeah. So what I'm just saying now, so it's a risk of the consumer accepting a non-conforming lot, right? So now what is associated with the consumer's risk is what we call a limiting quality, right? So a limiting quality is defined as the percentage non-conforming in a batch or lot, right? Which the consumer the con we the consumer which is the probability of acceptance to be low, right? And then the limiting quality is the highest defective level, right? That would be unacceptable to the consumer, right? So now, as like like we have an acceptance number, right? So we have that acceptance number, right? And then, like, let's say the limiting quality, as I'm saying, it's the lowest defect level that consumer would be willing to accept. So it's used to, in a sense, used to help you determine your C value, right? So like your C value, like it's sort of like a cleaned up version of the limiting quality, right? So now if you're let's say if you go back here again, if you go back here, right again. So if you see like for like let's say as you can see the acceptance number, the limiting quality, sorry, yeah, the limiting quality, right? It's expressed in proportion non-conforming, right? So let's say if they have a limiting quality of like a lower limiting quality of 2.6%, right? Which means now if you look at the corresponding probability of acceptance, it's 10%, it's low, right? So as the limiting quality decreases, the higher the percentage of acceptance, right? So yeah, I think we've covered what we need to cover for a single sampling plan. I hope to see you in the next video, which will cover the double sampling plan, right? So thank you guys for watching.